Assalamu alaikum everyone. Today we have to continue this chapter number 10, and today we will see the discounted profitability criteria, and we will see some of the equations that we can use in terms of time, value and money. Okay, so the first criteria that we will see here, it is the time criterion, and in this criteria we will try to calculate the discounted payback period. So what is a discounted payback period? It is the time required after the startup to recover the fixed capital investment FCIL required for the project with all cash flows discounted back to the time zero. Okay, so in this one, discounted payback period, we have to estimate the total investment that we can recover as a fixed capital investment from the start of the project, and all the cash flows that we calculate, we have to bring them back to the time zero. Okay, we will solve one example that will give you more insights about calculating the discounted payback period. The project with the shortest discounted payback period is the most desirable. Okay, so it is quite similar to the thing that we studied in the previous lecture. So if the payback time it is less, the project is more feasible. Okay, now in terms of cash criterion, we have to estimate the net present value. So what is the net present value? Cumulative discounted cash position at the end of the project. Okay, so it is quite similar to what we calculated the cumulative cash position in case of the non-discounted profitability criteria. Now here we will calculate the net present value, but the calculation procedure is same for this one and also the cumulative cash position. Okay, present value ratio, so it is basically the ratio between present value for the positive cash flows divided by present value of the all the negative cash flows. Okay, if the present value ratio it is greater than 1, then it implies that the project is potentially profitable. Now let us see what is an interest rate criterion. In the interest rate criterion, we will try to see what is the discounted cash flow rate of return, or we will try to calculate the percentage or the interest rate. So the interest or the discount rate for which the net present value of the project is equal to 0, we can call that one as a discounted cash flow rate of return. Okay, so whenever we want to calculate the discounted cash flow rate of return, we have to consider that the net present value of the project it is equal to 0, and then we will try to calculate the value for the interest rate or the discount rate. If the discounted cash flow rate of return is higher than the internal discount rate, then the project is considered profitable. Okay, so there, whenever we make an investment for any project, we specify that what should be our rate of return. So that is called as the internal discount rate, and then we do all the analysis in terms of total cash flows, and we do the detailed analysis from where we calculate the discounted cash flow rate of return. And if the value for the discounted cash flow rate of return it is higher than to what we have specified for the investment, then we see that the project is more feasible, and we can invest that into that project to get some benefit. Okay, now let us solve this example. For a project described in example 10.1, determine the following discounted profitability criteria. We have to calculate the discounted payback period DPPB, net present value and the present value ratio. Now what we have to do here, assume the discount rate to be 0.1 or 10% per annum. The procedure used in the similar to what to the one used for the non-discounted evaluation shown in the example 10.1. So basically, if you are able to solve the example 10.1, you know that how to calculate the non-discounted cash flows, and then we include one more parameter into those calculations, and that would give us the discounted cash flows. Okay, so the discounted cash flows replace the actual cash flows. For the discounted case, we must first discount all the cash flows in the table E10.1 back to the beginning of the project times 0. We do this simply by multiplying each cash flow by the discount factor P by F IN. So you can see the relevant table from where we can convert the final value to the present value, and we have been using that table a lot in the chapter number 9. Okay, so we will follow that table again to get the value for the present value. where n is the number of years after the start of the project. These discounted cash flows are shown with cumulative discounted cash flow in the table. Okay. Now let us see what we have in this table here. Now, first of all, we have to calculate the non-discounted cash flows. Now, for this non-discounted cash flows, if you go back to the example 10.1, so we have calculated this one already. Okay. So this one is these are the numbers that we calculated for the non-discounted cash flow. So this will be the starting point for our analysis when we calculate the non-discounted cash flows. Okay. So let's see how we can do this thing. Now here again we are having the non-discounted cash flows, and then we will try to calculate the discounted cash flows to incorporate the inflation or the time value of the money. Okay, so what we can do here, we can simply use this equation P divided by F, that is equal to 1 divided by 1 plus I with the power n. Okay, so you can get this equation here. Okay, so that is equal to F divided by 1 plus I, which is the interest rate, with the power 1. Okay, so you can have the new value for the discounted flow. Similarly, you can do this calculation here again, where in each year you would see there will be the rise in the number n. Okay, so you have to do this calculation all the way to the end of 12 year. Okay, so this will be the new discounted cash flow, and here we have calculated the new values for the discounted cash flow by including the inflation factor in terms of the discount rate. Okay, so now you see what is the difference. Initially non-discounted cash flow, the values were higher, but now the cash flows values are lower for the discounted cash flows. Okay, now the same way we have to add the previous term with the next one. So the cumulative discounted cash flow, initial value is 10, we can start from here, then we can add 10 with 81, we get the new value. We can add 91 with 74, the new value, and so on. Okay, so we can keep on adding these terms together until the year 12, and the number that we get here, it represents you the net present value. Okay, so this is quite simple, that how you calculate or convert the non-discounted cash flow into the discounted cash flow. And what we get here, net present value, and in the earlier case we get the cumulative cash position. Okay, so you should see the difference and what is the main changes here. Okay, now discounted profitability criteria here and discounted payback period. How we can calculate this one? Discounted value of the land plus working capital. So the land, it is here $10 million, then you have been provided with the working capital, that was $30 million, and then you have to divide it with the factor here again, which is 1 divided by 0.1 with the power 2. Okay, so the working capital you invest in the at the end of second year, right? So the value for n, it will be 2, and you have to do this one, 30 divided by 1 plus 0.1 with the power 2 to get the new value. So the new value in terms of number, it will be equal to 1.21. Okay, so this is the typo here, so you should replace this one with 1.21, and the discounted value of land and the working capital, it will be equal to $34.8 million. Now find out the time after startup when cumulative cash flow is this one. So the cumulative cash flow, if you want to calculate what is the payback time, so this one is the investment that we have made into the project in terms of the working capital. Okay, and we have to see that what should be the payback time. Now as the similar analysis that we did for the in the example in the earlier example 10.1, we have to do the similar things here again. Okay, so what we can do here, the total value for the project is, so here you can see the discounted cash flows, and here you can estimate the value for the fixed capital investment. So if you look at the figure here, which represents the fixed capital investment, this is $131.4 million. So how you're getting this value? The actual fixed capital investment for the project was $150 million, and those $150 million you invest that one into 2 years. Okay, so you have to calculate that one by the formula 90 divided by 1 plus I with the power 1, in which you invest the $90 million, and in the second year you invested $60 million and $30 million for you invested $60 million as a fixed capital, and here you invested $30 million as a working capital. So $60 million that you invested into the second year, so you can replace this this one with the 60 divided by 1.1 with the power 2. Okay, so that will give you the fixed capital investment is excluding the land, that comes out to be $131.4 million. Okay, so once you have the value for the $131.4 million, now you have to come back to this table again here and see that where you can add and get the value for the $131 million. Okay, so if you add these numbers here for the 5 years, you would get the value $118 million, and if you add the value for this year, it will be going $132 million. Okay, so you have to interpolate the result so you can get the value for the $131.4 million for getting the fixed capital investment back from the project. Okay, now the same equation or the same formula that we use in the example 10.1, we have to follow that procedure again here. So these are the number of years, 1 2 3 4 5. So 5 years would be there, and then for the rest of the value for the years we have to interpolate. Okay, so how we have to do here, 5 plus then we are provided with this one, the working capital that we have, and then we have to add this one with sorry, this one minus 47.34, which represent you the number which can you can see here during the interpolation. Okay, so here for the years, this one 1 2 3 4 and 5, so this one is the number here, minus 47.34 you have to use, and then you have to use this one minus and again this one minus with this one $34.8 million, and again you have to take this value again here, minus 47.34 from this table, and then you have to use the next value 33.98 here again. Okay, so this is the equation that we are usually using for the interpolation. Okay, so the value for the discounted payback time, it will be equal to 5.94 years. Okay, now you have to get the value for the net present value and the present value ratio. Now the net present value, for this value you have to go back to this table, and here the value is given at the end of the cumulative discounted cash flow, which represent you the net present value for this project, that comes out to be $17.12 million. Now present value ratio, so you have to add up all the discounted cash flows, the positive one, and divide it with the negative discounted cash flows. Okay, so what you have to do here, you have to add up all of these numbers together here, which are in positive. Okay, 28.71 all the way to 22.38. Okay, so you can see this one, all of these numbers are here, divided by the sum of negative discounted cash flows. So these are the numbers, 10 plus 81 plus 74. So you can see these numbers here with the bracket. Okay, so that will give you the discounted or the present value ratio. Okay, so that ratio comes out to be 1.10. So if the ratio is greater than 1, we have the solid basis that we can invest into this project, as it is more advantage, or it can earn more money. Okay, so this is all for the example 10.2, and here on this graph you can also see the representation of these numbers. So the discounted payback time, it is 5.94 years. Present value ratio, it is 1.10. Discounted fixed capital investment 131.4 as a net present value 17.12. Discounted land plus WC working capital. So you can also calculate this number by yourself. That will be equal to $34.8 million. Okay, now let us start the example 10.3 for the problem presented in example 10.1 and 2. So these examples are interconnected with one another. Determine the discounted cash flow rate of return. The net present value for different discount rates were calculated, and results are shown in the table E10.3. So this is these are some of the results. So the example 10.1, you have got the value for the net present value to be $170.50 million. You can see this one. Okay, so this one is the net present value, or the value that we get from the cumulative cash flow. Okay, so this one is the net present value, and then you can have the new value for when you have the discount rate of 10%. Okay, so you do all the cash balance and make the new table, and this is the value that you will get for the cumulative discounted cash flow, which you represent is the net present value. Okay, that is 17.12. Similarly, if you do the same analysis again for the percentage 12 in this table, you would get the new value for the net present value, that will be equal to 0.77. And similarly, if you increase the percentage to 13, 15 and 20, you would be getting the new values for the net present value. Okay, now what we have to do here, the value of the discounted cash flow rate of return is found at net present value equal to 0. Okay, so whenever we want to calculate the discounted cash flow rate of return, we have to consider that the net present value of the project, it should be equal to 0. So you can see this one, as we are increasing the discount rate or the interest, the value for the net present value, it is going to decrease. Okay, so we have to get the value for the net present value for the maximum interest rate or the discount rate at which the net present value, it will be equal to 0. Okay, so this is how we can actually calculate the interest rate that could give us the maximum profit. Okay, now for this example, a discounted cash flow rate of return, so we have to find this number here, and the basis that we have 12 and 13, so minus 12. So the number that we have for 12, it is for this one discounted cash flow rate of return, it is not given, so we can consider this one as 0. Minus for the 12%, we have this 1.77, and then for 13% we are having this value minus 6.32. For 12% we have the value 0.77. Okay, now the discounted cash flow rate of return, why we are considering this value 0, because at this point the net present value of the project will be considered as 0. Okay, that's why we are putting this value 0 here. So when we solve this question, we will be getting the value for the discounted cash flow rate of return, that will be equal to 0.109. Okay, so this value, once we have this value, we have to add up this value with this term, which is a 12% here, plus this number, that will be equal to 12.1%. Okay, so we are just doing the interpolation here to get the value for the discounted cash flow rate of return. Okay, so this is how we have solved this one. Okay, now you can also see the representation of this example 10.3 in this one, and you would see that for this for different discount rates, what should be the cumulative cash flow. Okay, and how we can actually earn more money by making these analysis. Okay, now this represents you the same calculation that we just did for the example 10.3, so it is just the replication of that one again. Now what we have to do, comparing several large projects, incremental economic analysis, discounted cash flow rate of return tells us how efficiently we are using our money. Okay, now we can actually make some analysis in terms of incremental economic analysis, and we will see that if we are having different investment opportunities, and we have some fixed capital amount that we can invest, so which alternatives we can actually choose which can give us the maximum discounted cash flow rate of return. Okay, so the higher the discounted cash flow rate of return, the more attractive the individual investment. Okay, so we have to see this number, discounted cash flow rate of return, to select between different alternatives to see which investment opportunity can give you the maximum return. Okay, now this is an example 10.4. Our company is seeking to invest approximately $120 million. So there is a company who have $120 million. After extensive research and preliminary design work, 3 projects have emerged as candidates for construction. The minimum acceptable internal discount interest rate after tax has been set to be 10%. So this one is set to be discount rate, or the internal interest rate is set to be 10%. The after-tax cash flow information for the 3 projects using a 10-year operating life is as follows. Okay, now for there are 3 projects alternatives. The initial investments are given, after-tax cash flow is given after 1 year, the value is here, after between 2 to 10 years. The range is given here for all the three projects. Now we have to see that which project is more beneficial, and we have to see that what is the net present value of each of the project and what is the discounted cash flow rate of return. So for this example, it is assumed that cost of land, working capital and salvage are zero. Okay, so these three terms are taken as zero. Furthermore, it is assumed that the initial investment occurs at time zero and the yearly annual cash flows occurs at the end of each of the 10 years of the plant operation. So these are the investments that are given here. At the year zero, there is an initial investment of $60 million. Okay, and then after end of year one, $10 million is generated, which is called as after tax cash flow, and from the tenure between 2 to 10 years every year, and you can get $12 million. And these are like the data for all the three projects, and we have to evaluate the net present value for the project and the discounted cash flow rate of return of each of the project. Now how we can calculate this one for the project A, we will consider. So the net present value, how we can calculate the net present value. So first of all, we are having this one. We will make the analysis that can give you the net present value. Now we have to see that how we can actually calculate the net present value for each of the project. So net present value we have to calculate at the time zero. Okay, so we have to bring all the investments back to the time zero. So we see here that at the initial investment we can have at the time zero minus $60 million. Okay, so we can put this one as such. Then at the end of first year, we after tax cash flow it was $10 million. So we have to bring that one also to the start of year one, right, or at the time zero. So what we see this one, how we can do this thing. So we have to use the equation P divided by F, that is equal to 1 divided by 1 by I with the power n. Okay, so here you are provided with the value for the F, which is $10 million, and then you try to calculate the present value at the start of year one. Okay, so the value or the number that you get here, 10 divided by 1.1. Now from the year 2 to 10 we have got $12 million annually. So what we have to do here, we have to again calculate the present value at the start of year one. Now the annuities are given here for the period of 9 years from 2 to 10, right? So we will use the equation P divided by A, and then we have to see that this one is the interest rate and n is the value for the n. Okay, so if you look at this equation, P divided by A, that is equal to 1 plus I with the power n minus 1 divided by I, 1 plus I with the power n. Okay, so that equation you can actually see from the chapter number 9. Okay, so once you use that equation, it will give you the present value at the start of the year 2, right? Because we are using this one as 9 years. Okay, so that will give you the annuity, or that will give you the present value at the start of year 2. Now we have to bring that value back to the start of the year 1. Okay, so we will multiply this one with an additional factor here, P divided by F. Now this term, it will act as a future value, which is the value at the start of the year 2, and then we will use this equation P divided by F, that is equal to 1 divided by 1 by 1 plus I with the power n. So that will give you the present value at the start of year 1 now. Okay, so we will use this one equation in the combination here, that will give you the present value at the start of year 1. Okay, so now you can add all of these terms together to get the net present value of the project, that comes out to be $11.9 million. Now to get the value for the discounted cash flow rate of return, it is the value of I that results in a net present value to be 0. Okay, so as we discussed the definition of the discounted cash flow rate of return, it is the value of the interest that we get at the net present value of the project at 0. Okay, so we can keep this one equal to 0, and here we will simply put the values or the equations here. For example, 10 divided by 1 with the 1 plus I with the power 1, right? So now we have to get the value for the I here. Similarly, on this one, we have to use the relevant equation, the same equations that we have used here, but here we will not put the value for the interest rate, okay, because we have to find out the value for the interest rate. For example, for this equation, P divided by A, that is equal to 1 plus I with the power n plus minus 1 divided by I multiplied by 1 plus I with the power n, okay. So you have to use that equation as such, and from there you will make this equation, overall equation, equal to 0, and then you will get the value for the interest rate that comes out to be 14.3%, okay. So this is how we will get the value for the discounted cash flow rate of return. Now the same thing we have to do for the project B and C, which is not given in calculations here, so you can calculate these numbers by yourself also. So the procedure is quite similar and same, so you can follow that one by yourself and get the values for these project B and C by yourself, okay. Now let us solve the example 10.5, that is in continuation of the example 10.4. Determine the net present value and the discounted cash flow rate of return for each increment of the investment. Recommend the best option. Okay, now if you go back to this example here, so the cap value that you can have here for the investment, that is $120 million. Okay, now you have to see that which project is more feasible to you, or which multiple projects you can handle. Okay, so if you have the project A, so you have calculated the discounted cash flow rate of return. Okay, so if you invest the money into project A, then you still have $60 million. Okay, then which other project you can see. Okay, then you may think, okay, well, no, not this one. You can invest into the project B, project C, and then you can have invested more $40 million and do the analysis, and finally you can see if you invest totally into project B, then what could be the rate of return and the net present values. Okay, so for the same thing we have to do this thing here. So determine the net present value and the discounted cash flow rate of return for each increment of investment. Okay, so now here we will talk about only the increment. What we have to do here, project A to project C. So for the project A, you have how much money? For the project A, you have $60 million. Now for the project C, you have to invest $100 million. So the difference is $40 million, right? So you can see this one. This one is the $40 million, which is an increment here. Okay. Now incremental cash flow for I, that is $2 million. So for the I here, now for the I here, when you make the comparison between project A and project C, the difference for the I1, that is $2 million. And similarly, the difference between the years from 2 to 10, the difference is 20 minus 12, that is $8 million. So we have to use these numbers here. So for the I equal to 1, the annual increment is $2 million. Okay, and from year 2 to 10, then the increment is $8 million. Okay, now you have to estimate the net present value. So the procedure is same that we adopted for example 10.4. So this one is the amount that you have in an increment that you would put here. Then for the first year, you have to use the same equation, $2 million, and you would get the present value at the start of year 1, and then you have an increment of $8 million. So you would use the equation for the annuity to get the present value at the start of year 2, and then you multiply this one with the another part of the equation that will convert the that will bring the cash back to the present value. Okay, so this would be considered as the future value, and then you would bring that one year back at the start of first year. That would give you the net present value at the start of the project. Okay, so you can add up all of these terms together, and the net present value, it comes out to be $3.7 million. Okay, now in terms of percentage calculation, you would use the same equations. Now in these equations, you will not put the values for the interest rate because you have to now evaluate the value for the interest rate. Okay, so you can write down the same equation in terms of the complete equation, and there you will consider the net present value of the project to be 0, and then you will solve the equation to get the value in terms of percentage. That will come out to be 11.9%. Okay, now the same thing we have to do for the other alternative, project C to project B. So if there is a project C, okay, you invest some project money into the project C, and now you want to switch it to project B, or you have $20 million that you can invest more. So the increment is $20 million. So the same procedure that you have adopted here, you have to do it here again. Okay, so the difference of the increment, it is $20 million. Incremental cash flow for the first year, it is $10 million. Okay, so you can see this one is 22, and this one is 10. So basically it is $12 million for the first year. Okay, and so basically it is C2B, and so we have to see this one C2B. Okay, so C2B, it is 22 minus 12, it is $10 million that you get here, and similarly 22 minus 20, that is $2 million. Okay, so the numbers, same numbers you have to use here. That is here you can have the $10 million, here you can have the $2 million, and the same procedure that we adopted here. For this part we have to do it again. First of all, we have to get the net present value by using the same equation or the similar equation, and the net present value, it will come out to be minus $0.4 million. And when you want to convert that, and when you want to calculate the discounted cash flow rate of return, you would use the similar equation, but you will not put the value for the interest rate, and you will put the net present value equal to 0, and from there you would get the discounted cash flow rate of return to be 9.4%. Now looking at these alternatives or incremental cash flows, what you see here, it is recommended that we move ahead on project C. So project C, it is more beneficial. Okay, so you invest some money on this basis. You would see, okay, you can invest the money into the project A, where you can have the maximum discounted cash flow rate of return, and the balance money you would see that you can invest in project B or project C, and you have seen these analyses. Okay, so if you make the, or if you transfer the money of $40 million to the project C, what you see here, the discounted cash flow rate of return, it comes out to be 11%. And similarly, if you see, okay, from project C to B, if you send some money or you use $20 million, and the rate of return, it will be 9.4%. Okay, similarly you can also make the other analysis. If you invest money from B to C, or you invest money from A to B, what could be the new values for the discounted cash flow rate of return or the net present value. So you can have, like, this analysis can be done when you have some additional amount for the investment, and then you can compare that one for the incremental analysis or the incremental investment, and from there you can estimate the net present value and the discounted cash flow rate of return. That will give you the idea that from which project you can earn more money. Okay, so this is all for today. Please let me know if you don't understand anything. Thank you.